Hello everyone, welcome to this lecture video. In this lecture video, we're going to discuss virtual memory in the operating system. We start with virtual memory. What is virtual memory? How the virtual memory helping the operating system for a good continuous process. So virtual memory is a separation of user logical memory from the physical memory. It is a virtual memory can be needs to be in memory for execution. So logical address space can be therefore much larger than the physical address space. So allows address space to be shared by several processes. Allows for more efficient process creation. Virtual memory can be implemented via demand packaging and demand segmentation. So virtual memory in this picture we can able to see this is a larger physical things. Virtual memory that can be in the page 1 0 page up to the up to n number of pages. It will be connected to the memory map, then followed with the physical memory. Then it will be connected to the main disk storage. So in this disk storage we having the things, we having the memory virtual memory that is larger than the physical memory. So demand paging, we are talking about the demand paging. So bring a page into a memory only when it is needed. So less input output needed, less memory needed, faster response and more uses. So page is needed, reference to it, the invalid reference that abort, so not in memory and bring to memory. So page is needed, reference to it. So in this demand paging we have the only inputs have less input needed, and also memory wastage is very less, so faster response and more uses. Then page is having the more values and other things. So transfer of page to memory to a contiguous disk allocation, the swap out and swap in, we are following with the program A and program B in the main memory. So valid and invalid bit, we having the things during the address 0 to page default, valid invalid bit in the page table entries here. So page table and some one pages are not in the main memory, and followed with the physical memory, logical memory and page table. So physical memory we having the A, B, C, D, E, F, G, H, I, the logical memory, and page table 0 to frame, invalid and valid things we having the followed with this process. Then page fault, we having there is our reference to a page. First reference will be trapped to a operating system page fault. Then OS link looks at the another table to decide. So invalid reference are abort, just not in a memory. So get empty frames, swap page into a frame, then reset tables, validation bit equal to 1. So will include a black move, auto increment and decrement process. So what happens if there is no free frame? So page replacement, find some pages in memory but not really in use, swap it out, algorithm and performance. So some page may be brought into memory several times. So performance of demand paging, we having these kind of things. So demand paging examples and followed with the process creation. So here in this process creation, we have the virtual memory allow the benefits during a process, and also the copy and write memory map files. So followed with copy and write, we having the COW allows both parent and child process to initially share the same pages memory. If either process modifies shared pages, only then is the page copied. So copy and write allows more efficient process, creates as only modified as copied. So free pages are allocated from a pool of zeroed out of pages. So memory mapped files and the simplified access by treating file input through memory rather than the read and write system calls. Also allows the several processes to map the same file, allowing the page into a memory to be shared. So in the memory mapped files we have the in this picture we can able to see the process A virtual memory, physical memory, and it will be connected to the disk files, and process B virtual memory. These things will be connected togetherly for the memory mapped files. So in this page replacement, next we continue with the page replacement. So we can have the over allocation of memory by modifying page fault service routine to include the page replacement. Use modify or dirty bit to reduce overhead of page transfer. So only modified pages are returned to disk. So page replacement completes separation between the logical memory and physical memory. So large virtual memory can be provided in a smaller physical memory. So these are having the basic page replacement. Find the location of the desired page on this. Find a free frame. Read the desired page into a newly free frame. Update the pages and frame tables. Then restart the process. So page replacement have these kind of victims here. So page desired swap desired page in, swap out victim pages and other things. Change to invalid, reset page or other things. We having these kinds of process to having the values. And the pre-page replacement algorithms, we have the different kinds of concepts available in the page replacement algorithm. In this lecture video, we have discussed about the memory mapped files and CODL and process creation, demand paging, and also the page fault. We discussed about the basic virtual memory and demand paging in this lecture video. Thanks for watching. We can continue the next topic next video. Thanks for watching.